Let's apply what we've learned about sample statistics so far. The staff at a local pizza place serve a 16-inch pizza, but despite their best efforts, not every pizza comes out at exactly 16 inches. The manager has determined the size of the pizza is normally distributed with a mean of 16 inches with a standard deviation of 0.8 inches. With this information, what are the expected value and standard error of the sample mean derived from a random sample of 2 pizzas? Or how about 4 pizzas? The important information to pull from the previous slide is the population mean and the standard deviation. As we learned earlier, the sample mean should be the same as the expected value, and that's a characteristic of an unbiased estimator. So regardless of the sample size, the sample mean should be 16. However, the sample size will impact the standard error. The standard error will be smaller with a larger sample size. In this case, it is 0.57 with a sample size of 2, but 0.4 when the sample size is 4. Remember, when talking about the sample, the standard deviation is called the standard error to help differentiate the statistic from the parameter. An important feature of the sampling distribution of the sample mean is that regardless of the sample size, the sampling distribution of the sample mean is normally distributed if the population from which the sample is drawn is normally distributed. If the sampling distribution of the sample mean is normally distributed, then it can be transformed into a standard normal variable by subtracting from the sample mean its mean and then dividing by its standard error. Returning to the pizza example, we can use the information we have with the characteristics of the normal distribution to better understand the situation. First, let's find the probability that a randomly selected pizza is less than 15.5 inches, and then find the probability that the average of 2 randomly selected pizzas is less than 15.5 inches. Because the population is normally distributed, the sampling distribution of the mean is also normal. This means we can use the standard transformation to derive the probabilities of interest to us. First, we want to determine the probability that a randomly selected pizza is less than 15.5 inches. To find the probability, we must first find the z-score corresponding to 15.5 inches, given what we also know about the mean and standard deviation, and look up the probability corresponding to that z-score. We find the probability is about 0.2653, or percent probability is about 26.53%. Alternatively, we can also use the p-norm function in R to find the probability. So the p-norm function might yield slightly different results from a z-table because it's able to more precisely compute the values. And we see that with both scenarios here. So on line 4 of the module 7 notes, we're looking at probabilities when the population is normal. Our value of x, so the value we're sort of holding things against, is 15.5 inches when the mean should be 16 inches and the standard deviation is 8. In our first case, the sample is 1, so there's no need to add a square root. And we find that the probability is 0.2659855, which is close to 0.2653. Then when we have a sample of 2 pizzas, when we look at the standard deviation, we add the square root term. Here we take the square root of 2 because our sample size is 2. And we can run this line of code in the same way. And we find that the probability is 0.1883796, which is pretty darn close to 0.1894. So here we've used the p-norm function to find those probabilities under a normal distribution. And what I especially like to look at is the pizza distribution. And here we can see the different distributions depending on our sample size, where our distribution is the narrowest when we have a sample of 4, and it is the widest and flattest with a sample size of 1. What this shows us is that our precision improves as our sample size increases. I hope you found this video helpful, and I'll catch you next time.